Alright, student, welcome once again, and we have a trick question over here, and we have tan 3a being equal to 3 tan a minus tan cube a all over 1 minus 3 tan squared a, and we have to prove. So let's take it for instance. If we have tan 3a, now tan 3a can be written as tan into bracket 2a plus a, right? Then we have that, right? So now from here we have this relation over here, and this relation corresponds to compound angles. Now from compound angles we have compound angles identity. Compound angles identity, if you have tan, so let's take it for instance, we have tan a plus b. It is basically tan a plus tan b divided by 1 minus tan a, then multiplied by tan b. So that is for compound angles. Now from here, from this relation over here, we have tan 2a plus a, and we are going to write this in terms of that. So writing this in terms of that, we have tan 2a plus tan a divided by 1 minus tan 2a, then multiplied by tan a. So this is what we have, right? Now we have 2 also here, which is also correspond to double angles. So we have double angles identity. So from double angle identity, we have that if you have the tan of 2a, it is equal to tan a plus a, right? So tan a plus a can also be written as tan a plus tan a divided by 1 minus tan a, then multiplied by tan a. So this is a double angle identity. So what we are going to do here, now we are still here, so we are going to substitute tan 2a into this equation over here. So let's do that. So let's continue from here. So we have from here we have so we have tan 2a plus a being equal to, now tan 2a here is just the whole of that, so let's substitute that. So we have tan a plus tan a divided by 1 minus tan, it is tan a times tan a, so okay, so tan a multiplied by tan a, right? Then we have plus this tan a there, all divided by, then we have 1 minus, over here too we have double angle, so we substitute tan a, right, multiplied by tan a plus tan a, sorry, it is plus, then we have 1 minus tan a multiplied by another tan a, so all of that, right, and we have tan a left, then multiplied by tan a. So let's continue here. Now this is what we have. So what we are going to do next is that we are going to simplify this. So simplifying that, we have tan a plus tan a, which is just 2 tan a, then 1 minus, then we have here to be tan squared a, because tan a multiplied by tan a. Now over here it is multiplication, we are adding here, so we have tan squared a plus our tan a, so that is for the numerator. Then for the denominator we have 1 minus tan a plus tan a is just 2 tan a, then divided by 1 minus tan squared a, right, then multiplied by tan A. So basically this is what we have. Then from here, what we do over here is that we find the LCM. We solve for the numerator. So let's solve for the numerator. Now from the numerator, our LCM is just 1 minus tan squared A, because this is over 1. So we are forget about this, we are looking at the numerator. So looking at the numerator, we have 1 minus tan squared A as our LCM. Then this goes into that 1, then multiplied by that, then plus this goes into that, then the whole of this multiplied by that. So the whole of that, so we have tan A, then multiplied by 1 minus tan squared A, and this is for the numerator, divided by then the denominator. So we have the denominator, also the LCM as, in the denominator we have the LCM as 1 minus tan squared A. Now we can multiply this and that, so we consider this as tan squared. Okay, so over here to 1 minus tan squared A goes into 1, then the whole of this, so this multiplies 1, then we have 1 minus tan squared A, right? Then the whole of this minus this goes into that once, then it multiplies the whole of that. So we have 2, then tan A multiplied by tan A is just tan squared A. So that is it for the denominator. So we further simplify that. So when we further simplify that, realize that over here at the numerator we have tan 2 tan A. Then if we expand this, we have tan A, then minus tan A multiplied by tan squared tan cube A, all over 1 minus tan squared A. That is for the numerator. So still for the numerator, then we have the denominator over here. So in the denominator we have 1, then we have minus tan squared minus 2 tan squared. They are like terms, so we can add them. So we have minus minus, which is negative. So we have negative 3 tan squared A divided by the LCM. So we have that. So remember, equal to. Now from here, what we're going to do is that it is dividing. So we're going to change the division sign into multiplication. So we are changing from division to multiplication. That is what we're going to do. So we have over here tan A plus tan A minus tan cube A divided by 1 minus 3 tan squared A. Now we'll multiply. Now when we multiply, what will happen to the denominator is that the numerator here interchanges with the denominator. So the numerator comes to the top, then the denominator goes to the down. So we have 1 minus tan squared A, then divided by 1 minus 3 tan squared A. Now if you look at it, we are writing, we have the denominator over here is 1 minus tan squared. So we have 1 minus tan squared. So 1 minus tan squared gets rid of that, right? So what is left is that and that. So we have 2 tan A. So we have 2 tan A plus tan A. So let's take 3 tan A, right? Then minus tan cube, this plus that gives us tan A. Then we have minus tan cube A divided by that 1 minus 3 tan squared A. So you realize that this equation over here corresponds to what we are supposed to calculate, right? what we are supposed to find. So this is equal to our tan 3a. So therefore you can interchange them. So therefore you can say 3 tan 3a is equal to 3 tan a minus tan cube a, all divided by 1 minus 3 tan squared a. Then you can have that. Then we've proved, right? So it has been proved now. So thank you very much and for joining me in this section. If this is your first time on this channel, please hit the notification bell for more videos. I will see you in another section.